Hey, morning crew. Sorry I can't be there today, but I'm going to take you through the worked examples from today's work. So, today we're looking at applications of straight line graphs. Okay, so we're bringing everything that we've done together into some real world sort of application type questions. So we're looking at 9H today. So you need to have your notes out there. I'm going to take you through the two worked examples. Okay, I'm not going to do the now you try ones, I'm just going to do the main examples. Okay, so I'm looking at example 15. So you have a hiker that walks at a constant rate of 4 kilometers, okay, per hour for 4 hours. Okay, that's information we're given. Okay, in part A, we want to draw a table of values using T for time in hours and D for distance in kilometers. And we want to use T between 0 and 4. So what we're going to do is we're going to create our table, T and D, and we're going to go 0, 1, 2, 3, 4. All right, and we're going to see what's happening. So we're going to assume now, okay, that when we first started, okay, well, time was 0, okay, because we're just starting out and we're not moving yet. So we're going to assume that our distance we travelled is 0 because we haven't gone anywhere. We're starting at the starting point, okay? Then after 1 hour, well, we've been walking at 4 kilometers an hour. So after 1 hour, we've gone 4 kilometers. After 2 hours, we've gone 8 kilometers. 3 hours, 12 kilometers. 4 hours, 16 kilometers. Okay, so that is part A. We've got our table. Now, most common and incorrect thing to do would be to have X and Y, because we've done tables of values like this in the past, but we've had X and Y. Okay. This time, now, the next part, we want to draw a graph. Okay, we want to draw a graph by plotting the points in part A. Okay, so I set up my axes here. I'm going to go 4, 8, 12, 16 for our distance. Okay, so 4, 8, 12, 16. You don't have to put a mark for every single hour in there, but remember these need to be evenly spaced. Okay, and then my time, I got 1 hour, 2 hours, 3 hours, and 4 hours. And this is my time over on this axis. Okay, distance this way, time this way. Okay, again, most common incorrect thing to do is either mix them around the wrong way or to label it X and Y. It's not X and Y, it's time and distance. Okay, now we've got to plot our points so we know. Initially, we're at 0, 0, then we're at the point 1, 4. So 1, 4, then we're at 2, 8, so 2, 8, 3, 12, 4, 16. Okay, now I've plotted my points, but now I want to join them up. Okay, and we're going to get a nice, well, it should be a nice straight line. Okay, use a ruler for this stuff. Okay, help you out. Okay, so we've got our graph now. So that's part B. For part C, we need to write a rule linking distance with time. Okay, so we want D, again, it's not going to be Y. Okay, we've got D equals something to do with T. Okay, so if we look back to our graph here, remember our work that we've been doing with creating our equations for our graphs? Okay, we look and go visually, where's my y-intercept? Okay, well, it's here. It's at 0. So I'm gonna, my C value at the end would be 0, like plus 0, which we don't need to write. Okay. Then we need to think about our gradient. Okay, how much do I go up by how much do I go across? Okay, so for every 1 across, I go up by 4. So if you like, my rise is 4 divided by my run of 1, which is just 4. So my distance equals 4t. Okay, so for every 1 hour, I go 4 kilometers. Okay. So that is part C. Part D is use your rule to find the distance traveled for 2.5 hours of walking. Okay, so now I'm using my equation. I want to find out how far I go. So I'm going to say my distance equals 4 times my time, which this time is 2.5. Okay, well, 4 times 2.5 is 10 kilometers. Okay, so in 2.5 hours, you go 10 kilometers. We can look at our graph here as well and go, well, here's 2.5. I tracked up, okay, hit my graph, track across. I'm going to see that I'm at 10 kilometers there as well. Okay, and then our last part is E, okay, where we want to use our rule to find the time taken to travel 8 kilometers. So this time I'm saying I've still got my rule distance equals 4t. This time though, I'm not told my time, I'm told my distance. So I have 8 equals 4 times t. Right? Now again, you could just read from your graph with this, yeah? This is one of our points we know. But actually, algebraically, how do we get there? Well, I've got 8 equals 4 times t. The opposite of timesing by 4 is dividing by 4. And I've got to do it to both sides. 8 divided by 4 is 2. 4 divided by 4 is 1, so they cancel out. So t equals 2, or 2 hours. Okay? So look, that's each part of this question. If you want to pause it now, okay, that way you can get this down in your notes. Okay? So pause it now. Let's go rub this out. Okay, so now, hopefully you got that one down in your notes. Okay, we're going to have a look at worked example 16 now. Okay, so we have the initial volume of water in a dish in the sun is 300 mils. So I'm just going to write this down and see what I'm doing. I'm noting the important stuff. So I've got the volume equals 300 mil. Okay, the water evaporates and the volume decreases by 50 milliliters per hour for 6 hours. Okay, so every hour we're going to reduce down by 50 mil. So again, I'm going to draw a table. This time I've got time. Okay, because it's still time. This time it's going to be volume. Okay, last time we were distance, this time it's volume. Okay, and then we've got to fit all this in. So we've got time 0, 1, 2, 3, 4, 5, and 6. Okay, because they say it happens every hour for 6 hours. Okay, and we want to fill in our volumes here. So we're not starting at 0 this time, we're starting at 300, because you have 300 milliliters. Okay, and our volume decreases by 50 milliliter per hour. So we're going to go down by 50, give me 250, then 200, then 150, then 100, then 50, then 0. After 6 hours, it's going to be gone. Okay. Again, we need to draw a graph for this. Okay, so I'm going to have 1, 2, 3, 4, 5, 6. Made this one a little bit smaller to fit it in. Again, okay, so this is time down here. This is our volume here. Okay, remember each of these gaps needs to be the same. And I've got, I'm going to go 50, 100, 150, 200, 250, 300. Okay, so 50, 100, 150, 200, 250, 300. So I'm a little bit squished here because I'm limited with how much room I've got here, so you can see it on the camera. Okay, so we've got to graph our points now. So remember, this is A, on our graph is B. Okay, and I'll look, I'll go, well, my starting one, when T was 0, was 300, so I'm up here. Okay, after 1 hour, I'm down to 250, 2 hours, okay, 3 hours. I'm just pulling these points. Okay, and then I finished here. Okay, remember, that's not our graph. Our graph is when we join them up to get a nice straight line like that. Okay? So it's part B. Part C, write a rule linking our volume and our time. So we're going to need V equals something to do with T. Okay, again, what's the most common thing that people do wrong? X and Y, X and Y, X and Y. Okay, make sure we use the variables that they tell us in the question. Okay, so now, again, using our knowledge of creating our straight line graphs, my y-intercept, I can just read it off here, is 300. Okay, so I'm going to need plus 300 at the end now, it's not 0. Okay, and we're going down, okay, by 50 milliliters each hour. So when my rise is negative 50 divided by my run of 1, so negative 50 divided by 1 is negative 50. So I'm going minus 50t. So I start at 300 mil, and every hour I lose 50 mil. So it's negative 50 times t plus 300. That's going to be my equation that we need for part C. Okay. Now, just like our last example, okay, we're going to use this formula that we just came up with to answer a couple of questions. So use your rule to find the volume of water in the dish after 4.2 hours. Okay, so I get V equals minus 50 times 4.2 plus 300. Yeah, a few people might be freaking out going, how am I going to work out that? Okay, it's all right. You just use a calculator. You can pop this straight in a calculator, and after 4.2 hours, we're going to find this thing equals 90 mil. Right, 90 mil of water remains. Okay, so we just pop that straight in our calculator. Okay. For part E, so I'm going to squish it in over here. We want, this time we want, use your rule to find the time taken for the volume to reach 75 mil. So this time I want 75 to equal negative 50 T plus 300. Okay. What I'm going to do is I'm going to take my 300 away from both sides. So I'm going to be negative 225 milliliters equals negative 50 T. Okay. That's our first step. Now I've got to divide. Again, I'm starting to run out of room here. I'm going to divide by negative 50, and I've got to do it to this side, and that's going to cancel it out. And I've got to divide negative 225 by negative 50 as well, which is going to give me a positive number, which we'd expect because time is positive. Okay, and when we divide 225 by 50, we get a time T equals 4.5. Sorry, 4.5 hours. Okay, so there's a couple of examples. Now you should be having a crack at the Now You Try ones as well, okay, to make sure we're on track with these. And then look, we're straight into our questions. I'd expect that you get at least the fluency questions completed this session. Okay, but just remember our process. We're going to draw some tables of values. Remember, label them correctly. Okay, T and V in this case. Okay, it was T and D in the other one. Just remember, it's probably not going to be X and Y. Use the variables that they give you. Okay, when we're drawing our graph, make sure we evenly space all of our points. Okay, so we can draw it accurately. Okay, and then go through, create your rule like we've been doing in the past, and then use our rule to find our answers. Okay, so again, I'd pause the video now so you can get this example into your notes as well. Otherwise, good luck, and I will see you tomorrow.